Hello, good evening everybody. Today I am going to discuss about a chemical reaction which name is Baker-Venkatraman rearrangement. It is a name reaction. It is undergo in the presence of base catalyzed rearrangement. It will react under base catalyzed rearrangement of orthoacetylketone to beta diketone. Here you can see that it is a general reaction scheme of this particular reaction. Here it is a OCOR. You can take in place of R any functional group like CH3 or C6H5. In presence of base, it will undergo rearrangement, and in the third step, it will be hydrogenation takes place, and the final product will be formed at the end of this reaction. The important of this reaction is it is a synthesis of chromones and flavones. Here you can see the mechanism for this Baker-Venkatraman rearrangement. Here you can see this is the raw material of this rearrangement. Here we put OH, that is a strong base. Here base will abstract a proton from this compound. Here a proton, here it is a proton. One proton will be abstract from here and it will be converted into CH2 minus from CH3. Here you can see that CH2 minus will be over here. After abstracting a proton by base, here CH2 minus will be formed. This CH2 minus will be attacked on this carbonyl carbon because it is a electropositive and it is a electronegative. So that this electronegative minus charge will be attacked on this, and this double bond will be open up and the negative charge will remain on oxygen side. Here you can see this bond form. Here CH2 attacked over here and this bond fell and their oxygen linkage will be formed. So that after this step, oxygen the charge will be on oxygen is revert back to this bond, and this oxygen linkage will be broken down, and after hydrogenation this beta diketone will be formed. Ready? Yes. This is the second reaction which name is Canizzaro reaction. In the Canizzaro reaction, the compound should not have alpha hydrogen. Here you can see this is the benzaldehyde. Here the compound do not have any alpha hydrogen, and this will undergo the Canizzaro reaction. If there is a alpha hydrogen, then this compound will not undergo Canizzaro reaction. So the raw material is 2 moles of aldehyde compound which do not have any kind of alpha hydrogen. So here you can see this is the scheme of this reaction. C6H5CHO, C6H5CHO. That means 2 moles of benzaldehyde which undergo KOH. That means strong base. Strong base will abstract a proton from here, and finally we get a product which name is alcohol and the potassium. If we take here sodium hydroxide, then we will get a sodium salt of acid. If we take a KOH, that we will get a potassium salt of acid. And if we see mechanism for that, you can see this, there is no any alpha hydrogen. This is the carbonyl carbon and directly attach here hydrogen. So carbonyl carbon, here no any presence of carbon, so here no any alpha hydrogen. So in that case, that this compound will undergo Canizzaro reaction. If we put over here strong base, here OH indicates strong base will attack over here carbonyl carbon. Strong base act as a nucleophile, not act as a base due to not present of a alpha hydrogen. So this strong base will attack on this carbonyl carbon. Then if this OH attack over here, then C double bond O, one bond will be broken down and negative charge will reside on oxygen. So here you can see that this oxygen is attached to this carbon. Here this OH is attached over here. This oxygen one bond electron of one bond is reside on oxygen, and here hydrogen is as it is. Now we also have a second mole of aldehyde which also do not have any kind of alpha hydrogen. So after that, this oxygen this charge on that oxygen will revert back to this side, and this hydride shift will be done over here. This hydride will, this hydrogen will move over here with taking his electron. After that, this hydrogen attached over here. Here you can say that after this electron will reside over here, it will form C double bond O. R C double bond OH, and here you can see that this hydride shift migrate from over here to here. So RCO minus, this again this double bond, one bond is electron of one bond is revert back on oxygen side, and here you can say this formed as a negative charge on oxygen. So and this hydrogen ion is migrated from this side. So RC bond O minus HH. After that, this hydrogen will migrate, will donate, oxygen will donate this hydrogen from here to here. After that, C double bond O minus, here oxygen donate, that is why oxygen will cover negative charge and hydrogen will attach over here. So final product we will get RCH2OH, RCHH, RCH2 and O and H. H is directly connect oxygen minus getting this hydrogen from here, and here acid salt of this particular compound will be formed.